Hi, my name's Steve Hughes, and I would like to introduce my book Star Bites, in which I use the physics of kitchen appliances and cooking to explain the basics of astrophysics in a non-mathematical way. So we'll begin by looking at the fridge freezer. Now, inside a fridge freezer, it's the expansion of gas which cools the inside. A refrigerant gets forced through a little nozzle, it expands on the other side, and it cools in the process. In fact, you can actually experience that yourself. If you go like this, your finger feels warm on the end. Then if you go like that, it feels cold. It's the same breath, but what's happened, because your breath has been forced through your lips, it expands on the other side and produces cooling. Now, that's what's happened with the universe. The universe started off extremely hot and small in the Big Bang of creation, and since then it's expanded and it's cooled. And the average background temperature at the moment is a chilly minus 270 centigrade, which is very much cooler than you'll ever get in your fridge freezer. And that brings us onto the subject of microwaves. So we use microwaves for cooking things quickly. The universe, in fact, is filled with microwaves, but much, much weaker than the microwaves in your oven. You're not going to be able to do any cooking with the microwaves which are out there in the universe. Now, we're familiar with the blue sky, where sunlight has been scattered in the atmosphere and it comes into our eyes from all directions, and so we see a blue sky. Well, out there in the universe, there's microwaves which come in from all directions, so it's like a microwave sky, and that is from the moment when the universe became transparent. About 380,000 years after the Big Bang of creation, the electric plasma, it's like a kind of electric soup, which was there, suddenly became transparent. If you think of soup, which suddenly becomes actual soup that you drink, becomes transparent, just like water, that's what it was like. And that light that was scattered, it's called the surface of last scattering, has become stretched due to the expansion of the universe, and it's been stretched so much that now it's been stretched into microwaves. This is an hourglass full of thousands of grains of sand. Now, after the universe became transparent, after a very long period of time, stars began to form. And so there was a cosmic dawn, and the first stars glimpsed into existence. There are an enormous number of stars in the universe. In fact, the number of stars in the observable universe, which is the extent of the universe that is possible to see with telescopes, contains more stars than all of the beaches and deserts on Earth. In fact, about 100 times the number of stars as grains of sand. So quite an incredible fact there. So that brings us onto the subject of stars. And here, I've got a saucepan on the stove, and if I just take that off and so you can see it, and we can see it's pretty turbulent surface, and what we've got these sort of bubbles rising up from the bottom. Those are convection cells, and those are miniature versions of what's inside every single star, including our sun. And what happens, the hot plasma, that kind of electric soup we mentioned earlier, it rises up from the depths and it carries photons with it, which get released at the surface of the star called the photosphere, and then they can fly to us here on the Earth. Now, onto the oven, which we use for cooking food, and that actually relates to the cooking of the elements in the core of the stars. Now, in the case of our sun, hydrogen is fused into helium, and for larger stars, bigger stars, what will happen, that process will continue on, and the helium will get fused into carbon, then oxygen, nitrogen, and so on, silicon, and then finally iron. Now, what's interesting about the oven, you've got to have a certain temperature in order to be able to cook things. So, for example, we might have the oven set to 180 centigrade or Celsius, and we might cook something for 30 minutes. Now, it's no good, say, going right down to, say, like 90 and cooking for twice as long and expecting the same result. It's not going to work. Or even go down to 45 degrees and cook for 2 hours. That's not going to work, because we need a critical temperature for certain reactions to take place. For example, there's caramelization. When sugars melt, there's a Maillard reaction where sugars combine with amino acids, which produces the browning, like on meat and bread, which makes the food really tasty. Now, inside the star, the core, that's essentially like an oven, and certain temperatures have got to be achieved for the elements to be cooked. And in a large star, that process goes on, but it stops at the formation of iron. And the reason for that is more energy is required to fuse silicon into iron than is released in the fusion reaction. And so the reaction stops, a bit like sort of opening the oven and letting the heat out. So it will actually prevent a certain temperature being achieved in the oven if you were to do that. Now, that brings us on to the coffee maker. Now, in a coffee maker, hot water under pressure is forced through coffee granules, and the water becomes infused with the coffee. Now, in the case of a large star, when it comes to the end of its life, when it's fusing silicon into iron, it then undergoes a dramatic explosion called a supernova explosion, and the heat and the pressure is so intense that elements heavier than iron get fused. And so we get gold, silver, mercury, lead, platinum, iridium, uranium, elements like that all get manufactured in a supernova explosion. Now, the dishwasher is also connected to astrophysics. So if I open it up there, you see there's a bar which spins around, water gets forced through, and we get a spiral of water coming out. I haven't actually been inside the dishwasher when it's working, but that's what happens. Pretty much the same as a lawn sprinkler. You get some lawn sprinklers where the water gets forced through and you get this spiral of water which actually goes out across the lawn. Well, that's actually what happens with the sun. The sun has got these jets of plasma coming out, a mixture of electrons, protons, helium-3 nuclei, which sort of come out, head towards the Earth and beyond the Earth, and there's a kind of a spiral, heliospheric current sheet which goes out throughout the solar system. In fact, in the same way the Earth has got an atmosphere, the solar system has got the heliosphere, which is the influence of the sun. And when that solar wind spiraling out, when it actually hits the edge of the solar system and comes into contact with the interstellar medium, or the gas and dust amongst the stars, it actually becomes compressed and it forms a kind of magnetic bubble wrap. And the actual sort of diagrams actually look like that. It's like bubble wrap. People like bursting them, accidentally burst one there. And so what actually happens, there are very energetic particles called cosmic rays which come from a galaxy or galaxies far, far away, and they slam into this magnetic bubble wrap and they get slowed down, and then they get caught up by the sun's magnetic field and get dumped harmlessly at the north and south pole of the sun, and so they miss us here on the Earth. And cosmic rays will be really damaging if they did get through there. Some do get through, but a lot of them get absorbed by this protective bubble wrap around the edge of the solar system. There's a thermomix. I'm going to give that a miss. It's far too complicated for me to relate to astrophysics. So finally, we come back to the fridge, and this time we're going to look at the magnets. All fridges seem to be covered in magnets, so here's one here. Now, what's going on inside a magnet? We've got these tiny little currents, electric currents going around in a circle in the atoms, and that generates a magnetic field. So we attract it to steel. Now, deep down beneath our feet, there's lava swirling around in the center of the Earth, and that generates a magnetic field which goes far out into space around the Earth, like a kind of protective magnetic bubble. And that protects the Earth from that solar wind that we mentioned, and that's actually vital for life here on Earth. Because what happens, the magnetic bubble, that actually collects the solar wind and it gets dumped harmlessly at the north and the south poles, or at least the top and the bottom of the world, and we get the northern lights at the top and the southern lights at the bottom, the aurora borealis in the north, aurora australis down here in the southern hemisphere. Now, without that protective bubble, what would happen? The solar wind would be slamming into the atmosphere and it would strip the atmosphere from the Earth. And that'd be obviously bad, no air to breathe. And another thing, the reduced pressure would enable all of the water to boil and the Earth would become a lifeless desert like Mars. So that's the end of this introduction to Starbites. So if you're interested in finding out more, there's a lot more in the book, then please go to the Amazon website where you can get a copy.